Hello everyone. In this lecture, we will talk about the series clipper circuits. Topics which we are going to discuss in this lecture are what are clippers. Then we will discuss about types of clipper, then positive series clipper and negative series clipper. First of all, we will talk about what are clippers. Clippers are nothing but the circuits which can change the wave shape of the input signal. So that is why they are generally called as wave shaping circuit. Clippers are also called as wave shaping circuits because if this is a clipper, let us say this is a clipper, we do not know what is inside there, then whatever the input we apply to it, let us say if we apply any input given a signal like sinusoidal signal, then whatever the output we will get, we can change the shape of this signal. If this is the input signal and we want that only the positive half of the portion will be passed and negative half should not be passed, then we will get the wave like this, that only the positive wave is coming, positive wave, only the negative half cycle is coming while positive half cycle is not. So this can be done with the help of a circuit, wave shaping circuit, which is called as clipper. Because it is clipping means cutting some portion of the wave while passing another portion of the wave. So this is the simplest definition of that what basically are the clippers. Now the point is that how basically we do that, with the help of which type of element we can do that, and the simplest answer is a diode. That a diode is a device basically which has two terminals, one is P and another is N, and if P terminal is connected to the positive terminal of the battery and N terminal is connected to the negative terminal of the battery, then in that case it is forward bias and it behaves as a short circuit. So what happens that if we want to pass any signal, any portion of the signal, then we place a diode in the clipper circuit such that this diode becomes short circuited and hence it can pass the signal to the output side wherever we want to pass it. And if we want to stop it, then what we do that we make the connection of diode in opposite manner. That means we connect the diode P with the negative terminal and N with the positive terminal, because in this case the diode acts as open circuit and so it will not pass any output. So this is the simplest way basically how we can make a clipper circuit. Now depending upon the diode position and depending upon the wave shape which we want to obtain, we can have different types of clippers. So the type of clippers are defined based on that is shown in front of you. One is the way, first of all, let me draw for you that if there is an input signal this side and there is output signal this side, and in between there is a clipper circuit. Okay. Then we can say that there is a branch between input and output, this one, which can be said as the series branch, right? Because the output will be, the component connected in this branch will be in series with the input. And if we connect any component from this to this point between this line, this will be in parallel to our V in line, right? So this is your parallel arm and this is your series arm. So if the diode, as you can see at the left hand side, that if the diode is placed in the series arm, then this is called a series clipper. And if the diode is in the parallel arm, as you can see in this diagram, is in the parallel arm, then it is called as shunt clipper. So this is the basic classification, basic types of clipper, that is either series clipper or shunt clipper. And again, the diode position can be in both ways. Either the diode is connected in this manner or the diode is connected in an opposite manner. Based upon that, we define another class, that is positive series clipper or negative series clipper. So we will discuss about positive and negative series clipper in this lecture. So first of all, what basically a positive series clipper? First thing is the series clipper. So series clipper means the diode is in series R, whether in this direction or in this direction, but diode is in series R with respect to the input signal. Another thing is positive or negative. What does it mean? If we say that we have any input signal, let us say a sinusoidal signal like this, and we pass it through the clipper, we pass it through the clipper such that the output waveform which we obtain, let us say this is your output waveform and this is your input waveform with respect to time, then if the output waveform obtained is having only the negative half portion of the wave while no positive portion is passed. So positive portion is clipped. So the positive portion is clipped here also and here also, right? So positive clipper means the positive portion is clipped. So this is the simple definition. As written here, a series clipper is said to be a positive series clipper if it clips the positive half part of the input signal as shown here. This part is clipped and this part is clipped while the negative half part is passed. This is called as positive series clipper. Similarly, if we define a negative series clipper, then just opposite is the definition that if this is your input signal, this is your input signal, and if we pass it through a clipper circuit, then this clipper circuit will be passed as negative series clipper, negative only if the negative portion is cut, if the negative portion is clipped. So it will pass only the positive half cycles of the input signal, not the negative. In the negative half cycle, it will be 0. This is called a negative clipper. And in the case of negative clipper, negative series clipper, that means the diode is in series R, whether in this direction or in this direction, that we will see. Okay, so a series clipper is said to be negative series clipper if it clips the negative half part of the input signal, as you can see here. So let us draw the circuit for positive series clipper. So for positive series clipper, we have already said that the output should be. Now let us draw a circuit and let us see that whether it is a positive series clipper or negative series clipper, because we have two conditions, either the diode can be in this way or the diode can be in opposite this manner. Here you have the input and here across this resistance you are taking the output. So we can easily find out whether it is a positive series clipper or a negative series clipper. For that we have to analyze it in two cases. That means for the positive half cycle of the input signal, and then we will analyze the output for the second case, that means for negative half cycle of the input signal. For both the cases we will analyze and we find the output, and from that we will derive, we will obtain that whether this circuit is positive series clipper or negative series clipper. Okay, so if we are saying that the input signal is a sinusoidal signal, it may be any other shape also. Presently we are taking the example of a sinusoidal signal. So if we are saying that the input signal is a sinusoidal signal, and for the positive half cycle means we are taking only the positive portion of this wave, this one. Okay, then for this case the circuit will behave in the manner that here is a diode, this is the P terminal and this is the N terminal of the diode. Here is a resistance and this signal is applied to the input terminal here. That means positive is this portion and negative is this portion. So if this portion is positive, that means P of the diode is connected to the positive terminal and N of the diode is connected by this part to the negative terminal, right? So what will happen, that P is connected to positive and N is negative to N is connected to negative. So that means this is making this diode as a short circuit. If we are assuming that this is an ideal diode, then this diode will become short circuit and here we are taking the output. So if we analyze, simply apply the KVL in this loop, we can say that whatever the potential drop V in here, that will be equal to this, simply the potential drop across this resistance R, which is V out. So it means V out is equal to V in, or we can say that the output voltage wave will be like this, which is same as the input signal. So that means it is passing the positive signal. It is passing the positive portion, not stopping. So it cannot be a positive clipper, right? Then let us analyze the second case also to check whether it is stopping, it is clipping the negative portion or not, whether it is negative clipper or not. We have assured that it is not a positive clipper because it is passing the positive portion. So for second case, that means for the negative half cycle of the input signal, that means if V input is having this negative portion, then for this negative half portion, if we apply to the terminal, that means this terminal is negative and this terminal is positive of the input terminal, then here diode P and N and here R is there, across which we are taking the V out. So we say that the positive terminal is of the input is this one. So that means N is connected to the positive terminal, and from this negative terminal we can say that P is connected to the negative terminal. That means P is connected to negative terminal and N is connected to positive terminal. That means diode is reverse biased, and if diode is reverse biased, we can say that this is open circuit. And if this is open circuit, that means there is no connection from input to output side, and at the output we cannot get any output, and simply the output is zero. So we can say that for the negative half cycle, the output voltage is simply zero, right? So that means we will obtain the output waveform from the input waveform in this manner, that if input voltage is a sinusoidal signal like this, then the output waveform will be passing only the positive half portion and negative half portion will be zero. Again passing the positive half portion and negative half portion will be zero. So that means it is clipping the negative half cycle, and that means the circuit is of negative clipper, because as per the definition we have already discussed, I have already told you, the negative clipper is that which clip the negative portion of the wave and passes the positive portion. So since the output is such that the output positive half cycle is coming equivalent to the input, but the negative half cycle is not passing, so that is why the circuit here is shown as of negative clipper. And if we want to make a positive clipper, just the direction of diode will be reversed, and we can easily analyze in opposite manner that this circuit will behave as a positive clipper. So this is how we define positive and negative series clipper. Here in this lecture we have talked about only the positive and negative series clipper. In the next session we will talk about the shunt clippers. These are the references and the disclaimer agreement. Thank you.